Well, the physical characteristics of a plant can reveal a lot when it comes to the underlying genetics. This can help us answer questions like how much water does the plant use or how quickly will that plant grow. By linking traits to these specific genes, researchers are seeking to improve crops by providing higher yields for farmers and creating greater food security nationwide. The science of capturing these characteristics in plants is called phenotyping. We recently got a closer look at the phenotyping experiments taking place at the University of Nebraska Lincoln.
Until recently, phenotyping had been a very time and labor-intensive practice. In the not-so-distant past, researchers had to rely heavily on the looks, touch, and feel of a plant. However, now technologies such as drones, robots, cameras, and laser scanners can measure a field of plants in nearly an instant. One tool that has been immeasurably useful for phenotyping is the University of Nebraska's SpiderCam.
So SpiderCam is really a very advanced phenotyping facility that Nebraska has invested. And so we set up this field experiment. It's about 1 acre in size. And those experiments can ranging from the genetic study to a study of the nitrogen use efficiency or study of the biomass production for the energy crops. And really in the hope to find what is the the best performing genetics, right? The varieties in the field, or are there any ways that we can manage the nitrogen or water more efficiently so that we can either save those resources or enhance the efficiency of the plants to use those resources. So all those are within the objectives of our study. So phenomics in that sense is really very widely applied.
As one of only 3 of its kind in the world, this SpiderCam isn't the type of tech your everyday crop producer will have readily available on their operation. However, the work being done with this machine may someday be applied to unmanned aerial vehicles or drones.
Because you can imagine UAV is small and they are very much limited by their battery. And with that limited payload, what kind of scientific instruments you are going to use is very critical. And what time you fly the UAV is also critical. For example, we have always found out in order for you to understand the water use, like the drought stress of the plants, the best way to fly UAV is really not in the morning, but right after the mid-noon, in the afternoon when the plant is most stressed. Your chances to be able to look at the stress symptoms is highest when you fly the UAV that time. So therefore, SpiderCam accumulated a lot of the scientific evidences and the data so that we can translate those information better to the UAV systems. And the UAV is heavily used now for the plant breeding purpose, but also even for the larger acre management system. UAV is also used. So we can already see what I'm referring to as the transition of the technology from the pure research to the applied or the production system, and that's already happening with SpiderCam to UAV.
As input costs have continued to rise over the years, researchers working with the SpiderCam technology are already seeing how the data recorded with these systems can lead to better decision-making and ultimately mitigate a sizable fraction of necessary operational inputs.
Today we are doing research on nitrogen use efficiency and being able to identify the genotypes that is more efficient, and hopefully later on that we can incorporate those specific genes to the commercial varieties. And also we are looking at what are the best technologies really being able to tell which plant is more nitrogen use efficient, right? So that has something to do with using remote sensing and looking at the crop canopy. And the conventional knowledge is greener the plants are, probably more nitrogen they have in their body. But there's a lot more than that, right? So and the nitrogen is a very complicated issue inside of the plants, and there's various chemical forms of nitrogen. And the phenomics is trying to allow us to do better than we just shallowly looking at the greenness of the plants, but we're really trying to tackle a lot of other chemical forms that hopefully we can use remote sensing to to be able to tell what is nitrogen concentration, for example, in the plant's leaf. And those would translate into the more advanced technologies, maybe 5 or maybe 10 years later, when the technology cost reduced, then we can be able to apply that at thousands of acres out there, millions of acres.
As growing seasons come and go, the field phenotyping facility near Meade continues to churn out new data every year. Soon enough, you may see new applications of this technology readily available for producers in their fields. Reporting for Market Journal, I'm Bill Dodd.